Okay, hello guys. Welcome to our additional tutorial class for final revision. So today we will look on some of the important question for the final test. Okay, so here is the final exam for 2024. Was 2 hours. So as you know, the exam will start from 4:30 to 6:30. So you have 2 hours to finalize and submit your answer. So the exam will start with part A, the substructure component, and then part B is the superstructure component. So based on your student ID, the last digit of your ID, you will use relevant parameter just to avoid like copying from each other. So you need to look to the table, and based on your ID, you can find the parameters for all the questions. Okay, so as you can see here, we have some short questions. They may be less this year, but the concept is the same. So we have some short question and two big problems, or two like calculation problem for the substructure part. So for example, here this for slope deflection, slope stability. So as you know how we have two methods for slopes, or two charts to use for slopes. So this is one of them, and the other one was explained also in the revision, or not in the revision, in the lecture. I think you have you watched this lecture? No, not this one. I will show you. The other one, just break my here. So under week 7, lecture 5. So under week 7, lecture 5, this is the slope and stability part. Yeah, this one here. So either one of them will come in the test. The one already in the test 2024, or this time. Both of them are for slope, but different chart. So one can be using Hoek and Bray chart, and the other one can be using Stewart charts. Okay? Yeah, both of them are same power bar. Week 7, lecture 5. Okay? So if you go back to the PowerPoint, just note this one. This is for the test. So how can we solve question number 2, for example? If we read it here, I just want to add a page. So for this question, what is the important parameter we need to know? Or what is the given parameter here? So we need to know alpha. Alpha is the slope angle, and h is the height of the slope, constructed using homogeneous soil with unit weight of gamma. Gamma is the soil unit weight. And we have some other probabilities of the soil, cohesion and friction angle. So for the soil, we have C soil, gamma soil, and phi soil. So these five are 5 important parameters we need to know to solve this type of problem. So the requirement is to find the factor of safety for this slope using chart 1 below. So this chart is a Stewart chart. The other chart is Bray and Hewitt chart. Both of them are quite same, but let's.
What are the two names? Yeah.
The other one here, Hewitt and Bray chart. So the problem can be using Hewitt and Bray chart or Stewart chart. Okay. So this example or this question was using Stewart chart. So based on your ID or the last digit of your ID, you will have these 5 parameters. For example, here, let's assume the first parameter or the first set of parameters. So how much is alpha? 37, H 9, 17. So if we use these parameters for our example, so we have this is alpha 37, H is 9, okay, phi and gamma and C. Let's go back to see them. So phi is 28, C is 6.4, and gamma is 17. Can you memorize them with me? So 28, 17, 6.4. So 28, 17. Okay. So these are the parameter, and this is the chart we will be using. This one is easier than the other chart, Hoek and Bray, because here, how can we use this chart? We need to find the factor of safety. So the factor of safety will come from either x-axis or y-axis. But how we use the chart to find these two values? Because as you can you see Fs? Fs, this is the factor of safety we are looking for. So to use this chart, we need to first of all find the value of C over gamma H 10 phi, which is one of the values here, these values. So we need to specify what is the value on this curve. Okay. Then can you see this red plots? So each red plot represent alpha. What is alpha? Angle of the slope. So alpha is the slope angle. So using alpha and this value, we can find which point or which curve we need. Okay. What? Which one?
So you know how you said the angles are alpha, right?
Yep.
Then with the orange dots near 0.4 and all that, would that be the height?
This is the height. What do you mean by height? Alpha? Alpha is here. Alpha is the slope angle. So if this is our slope, so the angle of slope is this is alpha. Okay. So how much alpha given? 37. Okay. So the first step, you need to find this value here, C over gamma H 10 phi. Number 2, using alpha you have 37. So how much C? 6.4. How much gamma? 17. How much H? 9. How much 10 phi? 10, 28. Okay. So from here you can find the value of this formula or this value, which is 17 times 9 times 10, 28. So it is 0.078, or let's say 0.08 if we round it up. So now, step 3, using 0.08 and alpha 0.37, go to the chart. So now we can go to the chart using these two values. So Can you spot 0.8 of the curve? So this is 0.08. So we will draw the line. This is our line until reaching to 0. So each dotted line representing this value. Okay. Then we need to spot the curves or the plots. Which plots to use? 37. So we have here 30 and 40. So it will be between these two, right? So our curve, we can take it as almost 35 or close to 35. Let's do it with a different color.
How did you find value?
Yeah, this is alpha. So this alpha 90, alpha 80, alpha 70. Each one of them is alpha. So this numbers representing alpha.
Yeah.
So
Why would you choose 30 and 40? You could have
because we
done
are
this.
alpha 37. So are looking for alpha 37. Okay. So this is our curve. Something between 35 and 40. So they intersect at a point. So this is our point we are looking at. Okay. So from here you go horizontally. This is the first value here. And you go vertically. This is the other value here. So we have value number 1 and value number 2. So we will go to the chart to get value 1 and value 2. For value 1, how much is value 1? Yep, so this is value 1. So tan phi over fs equal to the value we got. How much is this value? It is between 0.4 and 0.5. So you can, if you want to get it accurate, so you can measure from the scale, or almost we can take it as 0.45. Value number 2, what is the axis function? C over gamma h fs. So we have C over gamma h fs. What is the value here? This 0.02 and this 0.04. It is maybe 0.031 or 0.032. Okay. So 0.032, for example. So using these two values, you can find two values of factor of safety. Actually, it should be equal. So the factor of safety from here and here should be same, but due to the inaccurate of measurement, so it should be close. Okay. So from value 1, so we have how much is tan phi? How much is phi? 28 divided by factor of safety equal to 0.04 or 0.45. So we can get factor of safety. Can you get factor of safety from here? It will be 0.45 divided by 1028. So 0.45 divided by 1028. This gives us a value of 0.846. The second value, from the second value we have C. How much is C? 6.4 divided by gamma. Gamma is 17. H is 9 times the factor of safety equal to 0.032. So from here, can we get factor of safety or not? Factor of safety will be 6.4 divided by 17 times 9 times 0.032. This will be equal to
in this scenario, how come the 0.032 doesn't go, isn't times by the 6.4, like doesn't go as a usually?
yeah, because it is on the other side. So this will go when it go here. So this go there. So it is like you need to multiply by factor of safety in both sides and divide by 0.032 on both sides. So if you multiply this on both sides, this will go with this, so we still have Fs. There it will be below. Okay. When you move a term from the denominator, go to numerator on the other side, or from numerator go to the denominator. Okay. We just have a small problem here. The small problem is what is the accurate. The result is not, the values we got from here is not accurate. So I will just try to get it accurate. Otherwise, there will be big variation. So this is what you need to do. Otherwise, both values will be too much gap between them.
So we need to be very precise.
Yeah, otherwise it will not be. Yeah. So let's, yeah, because better I do it by hand because I am explaining to you, but if you do it by a line here. Okay. So this one may be 0.44. Do you have a ruler? You can measure, can you measure from the screen or not?
Where do we from the screen?
Yeah, you can measure from 0.4 to 0.5 and then measure this part and get the percentage. Do you know that? But I can't do it with Adobe. I can do it with Revo. Have you used Revo, the what, Bluebeam?
Bluebeam, yeah.
Yeah, you can do it on Bluebeam, but we can't do it here.
Would it be better if for this one, let's say if this was in the exam, that somebody's already printed that out.
Yeah, if
we
it's
could do, like,
printed,
a real life rule
yeah.
and just
yeah. But I mean, if you are using it online like this, so yep.
what's gonna do it and punch it home.
Yep. So let's assume this 0.43 and this point 0.31 or something. The problem is the main thing is the procedure. Do you understand the procedure? That's it. But I mean, if you want to get accurate results, so you need to get the correct measurements. So
But like you said, we can find difficulties in getting accurate.
yeah, but I mean, it's okay. I will.
Like, let's say this question, I'll work.
Yeah. Yeah, that's it. We are marking for the procedure, not for the. Yeah, but I mean, like, mathematically, the two values should be equal because the two lines are identical.
Can't we just hypothetically, whatever we get for X, we can just do it for Y, because you said they should be the same.
Yeah,
So
yeah.
technically, we can, if, let's.
Get it from one side.
Yeah, so we can say 0.4 for one side, then.
The other
we can
side
do it
should
for
be.
the other,
Yeah.
which
Yeah.
is accurate as possible.
Yeah. So, let's assume here this value is 0.846. This one, if we assume it, if we get it as 0.3, so 6.4 divided by 17.
But the rest is true.
Okay, so if this 0.35, if you get the correct measurements, so this one is almost 1.16. Okay, so this 0.35 if we get better or more accurate results, these two values should be equal.
So yeah, but we can also play with that number until we get an accurate.
Yeah, that's what I was trying to do. But if you make the correct measurements, you will find it close. Yeah, so if you return back to the example from the original slides, this was similar example. You see here, what is the value of this parameter? It was 207. So this 207 here, make a straight line, and this is the line of the alpha. Alpha equal to, alpha here was, how much alpha? 25. So for alpha 25, this was the value. So this is our intersection point. We do a straight line this side, straight line this side. So this is the two values we got. The vector of safety from the first one, 2.37. From the other values on the vertical axis, also 2.36. So this is how much close they are, almost equal. Okay. Anyway, this is how to use this chart. Is it easy for you? Okay. So if we go back to our slide, this is one of the example in the test. As you can see here, please present a screenshot of using the graph and add it to the answer. Because what is the answer here? If you didn't show this graph, this means you get the values from a different student, right? Or from somewhere else. So the proof you have done this is you show a screenshot of that. So that's why this note was written here. Okay, so now this one of the problems. Second problem is about pavement. Okay.
So wait, is that the first one done?
Yeah, that's it. So you need to get the factor of safety on. So the next one is two parts. So a new access route is to be designed for a mine site. The mine will be operational for 18 years, 7 days a week, 51 week per year. One track type will be running as shown as in figure 2. So this is the running track. The track will be running 48 times per day during the design life. So assuming all the axle group carry n% of the standard load, calculate the design DSA of the route. So DSA is the design estimated standard axle. So this is design estimated standard axle load. So this is the unit to measure the load coming from the axle of the trucks. Okay, DSA equal to the time operational of the truck times ESA. ESA is the estimated standard axle load. This multiplied by how many times this axle group was running. So number of years multiplied by number of days per year multiplied by number of times per day. Okay, so all this, the number of running of the truck for the whole design life. So ESA is calculated only for one time of running. Then you multiply by number of running per day. So this will be in 1 day. Multiply number of days. So this will be for 1 year. Multiply by number of years. So this will be for the whole operational time of the truck. Oh, okay, or the mine. So we need first to find what ESA. how to make or how to find ESA, we need to create a table. So an example of that is in week 12. If you go to week 11. So week 11 we have the road pavement. So if we look to road pavement part 2, this example here or this part here show how the ESA or the equivalent standard axle is calculated. And this is the loads for standard tire. So we need this information we will use in our calculation. So for single axle, how much is the standard load? 53. For single axle dual tires, 80. For tandem axle dual tire, 135. For tri-axial dual tire, TRDT, 181. So
do
this
we
is the shapes of the axles.
So do we always refer to this?
Yeah. So the truck given to you will have number of axles. So the load of each axle will be found or will be assumed using this table here. So for example, this truck, the first one is single axle tire, single axle, single tire. The second one is tandem axle dual tire. Tandem means two axles. The third one or the trailer one, how many axle? 3. So that's why 3 tri-axle dual tire.
3 times.
3 axle, each axle has 2 tires, dual tires. Okay. So this is the rule or the formula to convert the non-standard axle to standard axle. So ESA for this, because we have like, as you know, we have standard axle and other axle may be non-standard. So to convert from non-standard to standard, we are using this formula. Okay. So the formula is non-standard axle divided by standard axle to the power 4. That's why this law is called the force power law. So to solve this type, to find the ESA, we need to make table like this. So for example, this example has 2 trucks, but in the test, it will not be enough time to do one, or one is enough for a test. So you will find the test containing one of the trucks. Yeah.
Yep.
So we might have a small one or big one. So we have, for example, if you have more than one truck, so you need to do it for truck 1. For example, truck 2 and so on. Okay. So for each truck, you will need to get the ESA for each axle. So for example, the first one here, truck 1, how many axle we have? 2. The first one is single axle, single tire, so SAST. The rear axle or the drive axle is TADT or tandem axle dual tire. Then you will have axle load. Then you have a standard load. So this axle load will be given to you in the test. Okay. The standard load from where? From the table we mentioned earlier. From this table. So the standard axle are given using this table here. So for SASDT 53, SADT 80, TADT 135, and TRDT 181. Okay. So the third, this part here, ESA, will be the axle load or the non-standard axle load divided by the standard axle load to the power 4. So the main thing, don't forget the power 4. So you will do this for each axle. So for the truck, how much is for the truck? The summation of the axle. So if it's 2 axle, this 5.09 is 2.26 plus 282. For truck number 2, you have 3 axle. So you have number 1, 2, 3. So the total will be this plus this plus this. So total ESA for this two tracks, how much? This plus this. So it will be 5.09 plus 10.60.
But we're not worried about the last part, yeah, one shot.
It's one truck and it's gonna be a small one.
Yeah,
Is
one
that-
truck. So need to just find for one truck and add them together.
So the non-standard, where's that? We've got the standard load which comes from tech. Where did you get the non-standard?
Non-standard is
that
if-
the actual load?
Yeah,
Oh.
because some trucks are not like, for example, if they carry more than the original design, or if they make any modification, so it might be not non-standard. If it is a standard, so how much is this factor will be? 1. So if the standard equal to the non-standard, if the axle load equal to the standard load, so how much is this percentage? 1. 1 to the power 4 will be 1. So in some test, if you check the test, you will find sometimes it is given as similar to the standard load. But if it is not similar, so you need to divide this by this to the power 4. Okay? So you understand how to do it now? So if we go to our problem, so we will need to make a table. So the table will be how many trucks we have. We have only one truck. And we need to have, as you can see, axle and axle type, axle load. So we have axle type, axle load, and standard load. Okay. And then after standard load, you will have the ESA. How much is the ESA? ESA is equal to the axle load divided by the standard load to the power 4. So let's look to our example here. If you see the truck, how many axle for this truck or in this truck? 1, 2, 3, 4. So 4 axles. So we need to add one more line here. So we have steer axle and drive. So we still have steel drive, and we have trailer 1 and trailer 2. So this all the trucks you may expect in the test or in the
So after steer and drive, it just goes trailer 1, trailer 2, trailer 3, etc.
yeah. The name doesn't matter, but the main thing is what is the type of this axle. Okay, so how many axle here in our example, as you mentioned? 4. So 1, 2, 3, 4.
Is trailer always 3 tires, or it can be, how many can it be?
Yeah, 3. The maximum is try. So if you look to the table here, so we have single axle dual tire, this one. Single axle, single tire, this one. Single axle dual tire, this one. Tandem axle dual tire, this one. Tri-axle dual tire, this one.
So
Okay. So for our example here, we have 4 axles. The first one is SASDT. So we have trailer 1 and trailer 2. So the first one ST, single axle, single tire. The second one is what? TADT. The third one try. What is the name of the try? TRDT. TRDT. So what is the axle load? The standard load will come from where? From the table. Yeah, so it is 35. This one is 135 and 181. Okay, so let's read what is the given information here. So assuming the axle group carry N percentage of the standard loads all the time. So this N is the number of the axle load. So axle load equal to N percentage from the standard load. You see how it is given here? So based on your ID, so for example, if your ID 0, how much is the percentage? 70%. So the axle load is 0.7 from where? From what? The standard load. So whatever the standard load is, it is 0.7. So actually there is easier way to do it. But anyway, I will put here 0.7 times 53. 0.7 times what? 135. 0.7 times 181. 0.7 times 181. You don't need to find the ESA like this, because what is ESA? ESA equal to the axle load over the standard axle load, right? To the power 4. How much is this percentage already? 0.7. So this means ESA in this case will be 0.7 to the power 4. So here, what you need to do is 0.7 to the power 4, 0.7 to the power 4, 0.7 to the power 4.
That's easy one.
Yeah, so that's why it is easy. It is given to you easy. So all of them are 70% of the standard load. So you don't need to make calculation. So you will put N to the power 4, whatever the percentage is to the power 4. So how much is 0.7 to the power 4? It is 0.24. So each of this value is 0.24 percentage. So how much is the total ESA? It will be 2.4 times 4 equal to 0.96. So ESA for this example is 0.96. So how much now the DSA? DSA will be the number of years. How much is the number of years for this example? 18 years. Times how many days per year? 7 days times 51. So 7 days a week times 51 weeks. So this is the number of days per week, per year, sorry. So 7 days per week times the number of week. So this means that this mine will run for 357 days per year. Okay, so this is the total number of days. How many number of running this truck will run over this route for 480 times per day. So this doesn't mean that one truck will run for 480. This means that we will have more than one of this truck.
Isn't it 52 instead of 1? Is that
It was
the right
given.
way?
It was given.
It was given. Oh,
Yeah, they have 1 week off, like 1 week off. So it is given here. This mine will run for 18 years, 7 days a week, 51 weeks per year. So this number can change. For example, if they work 6 days per week, so you need to multiply by 6. Okay. If it's working forever, I mean, for every day, so 52 weeks, 7 days a week.
We just go with it on 10.
Yeah, that's why.
Slides.
So this 480. So this is the number of running. Number what? ESA. How much ESA we got? 0.96. So 18 times 7 times 51 times 480 times 0.96. This give us 2.961 times 10 to the power 6 ESA, or in other words, 2.96 million ESA. Okay? Is it easy one?
Well, okay, on the graph.
Well, I will do. This is the first part, so this was only for part A. For part B, using the calculated DSA and the chart in figure 3, this is the chart, determine the thickness for the base and sub-base layer of the root if the CBR of the subgrade soil is given or is CBR. So this number is based on what as well? The table. So this example is given in week 11 as well. Root pavement part 3. So root pavement part 3, if you look to this example, so this is considering the design factors for subgrade strengths. So we'll find a complete explanation about that and also examples. Have you seen this lectures or not yet?
Which one was that?
Week 11.
What we do? 13?
The one you was sick.
Yeah.
Yeah. Okay, so this is the chart we will use. We just here in this example, we need to find how much is the thickness of the pavement layers. So the pavement layers is depend on what? The loads coming to it from the traffic. So we are designing this route for the mine based on the calculation we did in part or the first requirement. So we will use the design ESA to get the thickness of the pavement. So that's why just one question and two parts of the question. So in this example here, as you can see, we need to use this chart to find the thickness of the granular material based on the subgrade percentage CBR and the DSA. So using the DSA you got and CBR, you come to this chart. How can we use this chart? So how can we use this chart using these two values? So here, how much is DSA? 1 times 10 to the power 6, for example. How much CBR? 3%. So let's say we have 1 million DSA and we have CBR of 3%. So here you will get at the DSA or the design traffic and put or allocate the value for the DSA. Here, how much is the value? 1 million. So I put 1 million and then I will go a straight line like this. Okay. Then this is the CBR percentage here. You will allocate this number here. And here, this is the minimum thickness of the base. So you have two values. One at the minimum thickness here. You see this part is the minimum thickness. So at the edge of this one here. So we have two intersection with these two lines. So at the minimum thickness, we have a line. We have this curve here. So they intersect here, and also at 3%, we have this line here. So how many points now? We have 2. Each one of the 2 will give us 2 thicknesses, one for the base and one for the sub-base. So at the first one here, this is the minimum. Just to remove this part. Can you see the minimum thickness of the base? So this is the minimum thickness of the base. So at this point, I will go with a straight line like this. So this will be my base thickness. So at point 1, minimum base thickness. At point 2, if you go straight, so this will be what? Sub-base thickness. Okay, not sub-base, this is the total thickness, sorry. This is the total thickness, and from here to here, the difference is the sub-base. So between the 2 points is the sub-base thickness. So what we will do, the first step, using ESA and the CBR percentage, you go to the chart. Okay, then using the chart, we will find the base thickness. For example, here, how much is the base thickness should be at this point? So from 0 to this point is, for example, 130 millimeter. So how much is the base thickness? 130 millimeter. Number 3, using the other point, you have the total pavement thickness or total thickness of the pavement. How much in this case? 510, for example. So number 4 will be the sub-base thickness. How much is the sub-base thickness? The difference between the two. So it will be 510 minus 130. So it is 380. So this one is straightforward one, using the values you get from 1. And then what you need to do as well, you need to show a diagram of the layers. Okay, so we will have like a cross section of the pavement. So this layer is the base, and the second layer is sub base. So how much is the base? 130. How much is the sub base? 380. So the total thickness, what we got, 510 millimeter. Okay, in the practical world or the practical application of the pavement, they are dividing the sub base to 2 layers. We can call it, because you know that we need to compact the sub base, so you can't compact 380.
Yeah.
380 is too much to be compacted at once, so that's why we have like 2 layers, or make it in 2 layers. So we have lift 1 and lift 2. So this is actually a diagram showing the pavement layers based on what? Based on the calculation we have. Okay, so let's apply this to our example or our question in the test. So if we add one more page here. So what we got we have DSA from our calculation equal to 2.96 million DSA. or approximately we can take it for this example as 3 for just for make it easier. And how much CBR based on what? Based on your ID. Let's assume same ID, so 2.5. Okay. So what we need to do? We need to go to the chart. So if you go to the chart, the chart is already given to you here. I will make it bigger. So how much is design ESA? 3 million. So we're here. This 1 million. So 2 million, 3 million somewhere here. Is that correct? If we make a line, straight line,
My question is, what's the 10.5, 10.6, 10.7, and 10.8? Because can't three be between those?
10.5 means 100. So this means 100, 100,000. Yep. So 100 million, sorry, 100,000, 1 million, 10 million, 100 million. Okay. Here we have 3 times 10 to the power 6. So this one to the power 6, then 3 to the power 6. This is our value. Then we need to add a line here. No, it does not fit. How to move this one? Okay, so this is a line, a little bit inclined. Okay, so understand it now?
In the old test, how did students normally write or draw a graph? Was it all online or did they?
What? You can do it manually, but you will need to print the,
So it'll take too much time, basically.
yep. If you have a printer already. So I think electronically will be easier, like for the graphs, if you work on the graphs. But for the hand calculation, you can do it because you will be reducing and scan. So only the graphs. If you have a printer, so it will be easy for you, but if
So
not,
how are we gonna get given the exam? Is it just like a Word document which will be released or?
yeah, it will be released on the exam date.
Yeah, no, but like, is it like a Word document, PDF, or how is it gonna be?
Yeah, PDF or Word. Yeah.
So not like a uni way?
No, just a file like similar to the course slide or something, and then you download and work on it. Okay, so this is the first thing. Where is 2.5? 2.5 is somewhere here. This is the CBR, as you can see. So 2.5% is here, for example. So here. Okay, so we have, where is our 2 points now? Our 2 points are here and here. This one, and this is 2. Okay, 1 for the base and 2 for the total. And the difference between them is the subbase. So what you will need to do again is using these two lines, you will need to create two horizontal lines. This one is how hard is teaching online.
Yeah. Think of the whole thing. Like a page load. Or like country, is like everyone's at uni say. Then movement. Why should people really start mixing up their papers?
So how much is the thickness here? Yeah, so 1, 2, 3, 4, 5. So 640.
Oh, sorry.
Yep. So this one is
What the next word was going up.
640 here, and the other one
No, but you're gonna run out of time, bro. Seriously, look at the graph. No, that is not straight. That is not straight.
So we have, if this 200, so 200, 180, 160, 140. So this one is 140. Okay, so we got the two values.
Don't give it a really good point. No, that is crazy.
So from the charts, the base thickness, minimum base thickness is 140. Total pavement thickness is so the sub base thickness is 640 minus 140 equal to 500 millimeter. So if we draw a sketch for the layers, so this is the base, this is sub base, and if we write this, so this is the base, and this lift 1 or lift 2, and lift 1, and this total is the sub base. The thickness,
One off of two, like the number.
just because lift 1 will be made up before lift 2, so we will put the bottom layer first, and then. So here, this is the thickness. How much is this thickness? We got 140. This total is 500. So this total is 640. The lifts are, 250 each, for example, or 300 and 250, whatever. So this is the pavement layers. Okay. Easy?
Yeah.
Or good for the substructure now? Yeah. Okay, so this was for the substructure part. For the superstructure part, we have already done how to calculate the loads on the beams in the last previous revision lecture. This should be read or watch it with the lecture week 12. So this not separated from, I mean, this not replacing week 12. So week 12, this adding to it, okay? Because we already have gone through some of the question already. So this is just to do more exercise or more practice, okay? I mean, don't depend only on this one. So you need to look on the other one as well. So in the week 12 lecture, as you can see here, you will see that the system of the exam changed because more heating come to place. So that's why everyone has different set of parameters. You will see previous exam doesn't have, maybe it was face to face, some of them, because before COVID it was face to face. So that's why.
Why isn't structures one like that?
Why? Well, how
Structures
structure?
one is always face to face, no, over screen. I don't know, structures two is.
More
mostly
flexible?
online.
Yeah. But the lecture as well was face to face? Yeah.
The lecture, wait, the lecture was, no, the lecture wasn't, but like the tutorial, it was, yeah, but it was like grade based, like you got graded if you had to show up on your tutorial.
Oh, yeah. Yeah. This depends on how the tutor work or how the lecture work. But for the exam, it's called invigilated test or not non-invigilated test. So invigilated means you need to be if it is online, you need to keep watching to the screen. If you look anywhere else, the screen will lock. You know this type of tests. But we can't apply this here. Yeah.
It was like, if you look somewhere else, your teacher has to, it will alert your teacher, and then they'll probably have to say move your camera around, so they know you're not cheating.
That is all. It is like automatic. So the screen will the system will make something for you. The other option is face to face, and you come to like the normal or the traditional test. So
Try to get some glass of water.
Yeah.
Drink your water, then you'll get down.
the exam finish. Okay, so in this, as you can see, you will have like a plan or layout for the shed. So for example, we will focus on one column and one beam. Because this is mainly our topics during the course. So in week 12, we have done something like this. So calculate the design loads, dead load, live load, and wind load acting on rafter R2. So this is how to find dead load, live load, and so on. So if we add one question here to the rafter, I think you already have gone through it. If we ask about how to draw bending moment diagram and shear force diagram and so on, is it easy for you? So after you got dead load, live load, and wind load, so we can ask about the load combinations. Do you know how to do the load combinations? According to 1170.0. So we have 1.35 G, 1.2 G plus 1.5 Q, 1.2 G plus 1.5 epsilon L Q. Number 4, 1.2 G plus WU plus epsilon C Q. Number 5.9 G plus WU upward. Okay. So if you already calculated G and the Q and WU and you know epsilon L and epsilon C, for example, if we use a roof, so this will be 0. So let's assume it is 0 here. But do you know already how to get it, right? Or no?
What, let's see, isn't that just from the table?
Yep.
And then it just depends on what place you have.
But I will give it to you if needed. So based on if it is a roof, so it is 0. If the roof is non or inaccessible roof, this means nobody go to it. So epsilon L and epsilon C for this case is 0. Just otherwise it will.
Charger not working?
Yeah,
What charger do you use? I've got a spare one.
this one, this for surface.
Yeah, I would like that.
I have USB.
Yeah, you read, yeah, I can do that.
I don't know what is the problem.
Check this one in.
Thank you. I think it's working now. Thank you. Thank
Oh,
you.
it's working?
It works.
Okay.
Thank you. Because I am working on a dock at the uni and at home, so I only use this charger when outside. So maybe feeling angry. So if we know all this data, so you can find the load combination, right? So after we got the load combination, this will be maybe one of the requirements. So if I ask you what is the maximum load combination, so you need to find this 5, for example. So let's assume the maximum load combination is this one and this one. So this one for downward, if you remember the design of beam, the beam example, okay, or beam B1 in the design project. So beam B1 have the 5 load combination will be active. Okay, so this may be one of the question if I ask you what is the maximum downward load combination and what is the maximum upward load combination. But you need to, I just give you how to do it, but you need to calculate, okay? So for example, the next question is how to draw bending moment diagram and shear force diagram for a beam, for this load combination. So now you already know the load combination and you got the maximum load combination ED. So ED equal to 1.2 G plus 1.5 Q. Let's assume G is 2 and Q is 1. Can you find this value or not? I just assume to give you a number. So if we assume this value, so 1.2 times 2 plus 1.5 times 1. So 2.4 plus 1.5, so it is 3.9 kilonewton per meter or almost 4 kilonewton per meter. So if we have a beam 8 meter and we have a load of 4 kilonewton per meter, can you draw or find the bending moment diagram and shear force diagram or not? Okay. How can we find the shear force diagram and bending moment diagram? So this is the shear force diagram. This positive, this negative. How much this value is? WL over 2, WL over 2. So WL over 2 is 4 times 8 divided by 2. So the value of shear will be 16 kilonewton. So WL over 2, 16 kilonewton. Can you focus on the unit because the unit is important? So this is our shear force diagram. The unit of shear force diagram is kilonewton. What about the moment? So for the moment, for the bending moment diagram, the moment will be maximum moment where at midspan, and this value is WL squared over 8. How much W? 4. How much L? 8 squared over 8. So 32 kilonewton meter. The unit for bending moment, kilonewton times meter, not kilonewton divided by meter. Okay. Are this identical unit or different? Different. Kilonewton meter means times meter, multiplied by meter. Kilonewton slash meter means divided by meter. This is different. Okay, because this like 80% do this, so this is wrong. So this moment is positive, so this is our bending moment diagram. So easy, bending moment diagram and shear force diagram. Okay. So one extra one, not highly expected in the test, but just a reminder for you. How can we find the deflection for same beam? You don't know? Okay, so if we have a load of W and the beam span is L, so the maximum deflection delta equal to 5 W L to the power 4 divided by 384 E I. So this is the value of deflection. Okay?
It's not gonna be in the test.
No. Okay. So up to here only in the test. So
That's just the compound.
yeah, just a reminder. So this is the last part of the beams. So now we know how to calculate the load on the beam, how to find the load combination, how to draw bending moment and shear.
Oh, that's five. Is that a constant number or?
Yeah, these two are constant.
So superstructure, all we have to do is find the wind load, dead load, and live load of whatever member you've chosen.
Beam, yes.
Of beam, and then after that, go to the combinations.
Load combination and
choose
then
the highest downward and upward one.
yep.
And then from that,
Draw the bending moment diagram and shear force diagram. So this one is important. This one is important.
so you would rather us focus on the superstructure more than substructure,
Why?
huh?
Why?
Didn't you say it's worth more?
Yeah, but I didn't mention to focus on one. Yeah.
One than the other, but like.
Yeah. I mean, yeah, the weight on the test, this is double the weight. So the
Yeah.
superstructure is 2/3 and the substructure is 1/3.
Yeah.
Okay? But don't forget that you need to get 40% of the whole to
Right.
pass. Okay? Okay, so this was for rafter. For column, I will also add a new question for you now. So for column, column design. So for example, I will not ask you again to calculate the load for column because already done in the beam. So just not wasting because no time in the test to ask for everything. So for the column design, if I give you the dead load, N due to dead load, and N due to live load, and N due to wind load. So for example, 100 kilonewton and 50 kilonewton and 75 kilonewton. So this given already to you, and I ask you to find, because this was a problem in the project design, find the maximum axial load on the column. What is the maximum axial load mean? This is the maximum load combination for the column. Yeah. So, but here you don't need to calculate because it's already given to you. Yeah. So how much? What one? We have 1.35 G, similar to the first one. 1.2 G plus 1.5 Q. Number 3, 1.2 G plus 1.5 psi LQ. Number 4, 1.2 G plus WU plus 1. Plus psi CQ. Number 5 is 0.9 G plus WU upward. So if I give you this downward and we have another one like 35 for example, upward. So now you can use them to find this value. So for example here 1.35 times what? Yeah, not sum of the load times G. So N dead load is G. N live load is Q. N is W. So this W up, downward, sorry, and this W up. So 1.35 times 100. Here 1.2 times 100 plus 1.5 times 50, and so on. Okay? Then you will get again, for example, if this is the maximum load combination. So N maximum or the maximum axial equal to 1.2 times 100 plus, this is just the assumption, not, okay? Yeah, so for example, 120 plus 75, so total is 195 kilonewton. So if you design this column, you will design for N equal to 195.
So that's it?
Not this one only. So this is one of the requirements. The second requirement, for example, if you remember, we need to have the buckling lenses. So how many buckling lenses for a column? 2, LBX and LBY. Okay, so how to get this one from the, yep, maybe. This to replace this question here, okay? Because we need to have one question for rafter or beam, one question for column.
We can have one question. You have one question.
Yeah, but the one question of beam will have like points. Understand what I mean?
Oh, like.
Yeah, and instead of 36 on bar, so it will be like dot points.
Yeah.
Yeah. Like find load combination,
So
find.
I break it down 36 points.
Yeah. I mean, this one, because it is for a different course coordinate, so I will make updates on it. So the final look for the test will be in the sample test. I will show it to you. But that's what I'm doing now. So I am solving what you expect to, what is the question you expect.
So in the final exam, you're gonna have like 36, but you're gonna have the 36.
Not 36, we have 66 for the superstructure.
Yeah, no, like, let's say one question.
Yeah,
would be,
for
like,
example, I will make like 60 for beam and car. Let's say 40 and 20, or how, like something close to this. So 40 for beam, this will include loads, load combination, bending moment, and shear. For column, expect load combination, buckling, and go to the chart. So that we cover everything in the course. Yeah, okay. So just if we go here, so this is our, if this is our column. So if we have the column, to find LBX and LBY. Or maybe we can focus on one only. So, but I will explain now, and then in the test we may be reduced to make the time manageable. So if this our column, we are designing this column. So we need to find LBX and LBY. So if this hinge here, so this is our column. So the column here at the bottom is bin, and how to find LBX? So LBX, if you remember, it was K times L. So to find LBX, we should know L and K. So L is the column height, for example, 9 meter, 6 meter, whatever. So we know L. For K, based on what the column ends. So if we go to, I will give you this table in the test, but let's have a look here. Where is the column lecture? The column lecture is lecture 11. Okay, so if we go to the column lecture, do you know this table? So for this column will be in X direction or LBX, it will be a sway member, similar to the report, because nothing to prevent this column from sway. So this column will be one of these. So if it is fixed at the bottom, and because is it free on the top, or it's connected to the rafter? It's connected to the rafter in this case. So in this case, we will take it as 1.2 if it is fixed, and 2.2 if it is hinge or bend. So it can be either of these cases. So if we go back to our slide again. So what you can see here, is it bend or fixed at the bottom now? Bend. So if it is bend, how much K? 1.2. So LBX will be 1.2 times 9, for example. So it is 10.8 meters. Okay. If it is fixed, so it will be 2.2. You understand this one?
Yeah.
Is it correct or not? We reversed them, so 2.2 for bend, 1.2 for fixed. So just to show it in the video. So 2.2 for bend and 1.2 for fixed. So our case or our example we are solving is bend. So if it is bend, it is not 1.2, it is 2.2. So for bend, what?
Can you go back on the actual drawing, the warehouse?
Yeah, it
Well,
is not
yeah,
given.
that's
It is
it.
not given.
In the exam?
Yep. It was because I am just making a new question.
Oh,
So this was not in the question. So if it is like this,
yeah, because I thought.
yeah.
this-
So I will add something like this, for example, or like this. So it should be given to you to know if it's fixed or hinge. Okay. But here for this test, because it was not required, that's why it was not added to the drawing. Okay. So now, after we know 2.2 times 9, so how much 2.2 times 9? So it is 19.8. So for example, I will ask you to find LBX. If I ask you to find LBY, how much LBY as you know? In the out of plane, it is braced. So the column is braced, so it is considered as bin bid. If it is bin, how much K? K equal to 1. So if we go back to the table, how much is bin for the braced? 1. So for out of plane or LBY, all the time you take it as 1. What is the change will happen, or where the change will happen in LBX? So LBX can be 1.2 or 2.2 based on the support. Okay. So if we go back to here, so K times L. So K is 1 times 9 equal to 9 meter. So this for LBX and LBY. What is the last question we can expect for this column? After you have LBX and LBY and so on, what is the selection of the section? So I just want also to give you a question to select a cross section. Yeah. So select a cross section for the column. How can we select a cross section for the column?
Given a chart.
Yeah. So using the charts. With what we need to go to the chart? N maximum. We got already N maximum and what? LBX. This one case. I will ask you for one case only. So I will ask you to use LBX and N. Because if you remember how many cases we need to use the chart? 2. One time LBY and one time LBX. So
the
just
time
to,
is only gonna be on that.
yeah. So just to save time, so use LBX on. So using the buckling length LBX and N asterisk and the chart, we can find the section. How can we find the section? This is our design charts. Can you see the chart? Okay. So here LBX, how much LBX was? 19.8, for example. So here is close to what? 20. How much is the axial force, for example? Calculate 100 something. How much was N from the dot combinations? 195. So what we need to do with LBX equal to 19.8 and N equal to 195, you go to where the chart. So here is 19.8. Here is 195. Right? So I will create a line here. So this is our curve. So what is the design or what is the selection of this column? What is the best section for this column? 200 UC, 46.2. Yeah, but if it is on the curve, so take this one. If it is above, so it's already on this curve, so we will, using the chart, use.
Technically, there's no wrong answer as long as you go above the point.
Yeah, but if you go too much, it will be over design. For example, if you use 500 UC and we need only 200, this means you are wasting material. Yeah.
Depends on the question. If they're going for less economical, why you buy
Yeah, if we go like this, so you don't need to design. Go to the market, select the biggest one, so it will fit. Yeah, so if you are doing the work for a very rich client, don't worry about money. So, okay, so is it easy?
Yeah.
So,
So that's it.
yeah, that's it. All good?
Can we just go over the basics of what's going to be covered in the test? So, like all this
Yeah.
section, so we know what to revise for.
Yep, okay. So for the superstructure part, as you can see here, mainly we will have like the question I already explained in like the calculation of beam loads and load combination. Yep, beam loads and load combinations, and maybe I write it here. Beam loads, dead load, live load, and wind load. Number 2 is the load combinations. Number 3 is drawing bending moment diagram and shear force diagram for the beam. This for beams. For columns, we have the load combination again, and LBX and LBY. Number 3 is selection of the section using what? The charts. Okay, we will have maybe 2 or 3 very short questions. About, for example, the bracing importance, something like this, and also, for example, something about concrete, like concrete curing, for example, and also something about the reinforcement. This short question only. Okay. So for example here, this was example from previous year. What is the uses of this equipment shown below? Which one is intended for use in marine structure and why? So for example, A is used for marine structure because it is not from steel, so it is from plastic or something like this, so it will not rust or not corroded, no corrosion. So you can search, for example, before the test about the answer of this type of question, or roughly read through the slides of.
Can't you just, hypothetically, can't you just screenshot it and then put it into Google search and then it can just find out what it is for you and just tell you what it is?
Yeah, you can. That's why I don't want to bring it in the test, but just 1 or 2 marks, 3 marks. I know because everyone will be able to do that, like, so. And also, if you know it, everyone will know it. Just send through WhatsApp or something. So this type of question, like, everyone will know. That's why don't focus too much on it.
So you said short question was bracing, what was the other one?
Yeah, bracing and curing of concrete. You can find them in the previous years. So, I mean, this will not be the weight of the test. The weight of the test
Yeah.
will be on the calculations of beams and columns. The summary I give you here, this part here.
What about substructure?
Yeah, for the substructure part, also same thing. The focus will be on the calculation more than the short questions. But let's have a look on this test, for example. So for example, here's just one of the important question, like what is the difference between typical soil and saturated soil? This was sort of question. Yep. So typical soil means soils that have 3 phases of the soil, like solids, water, and air. Saturated soil means the air is filled with what? Water. Dry soil means the water was dried, so it will be solids and air only. So you understand the difference between these 3. Also, just the third one, for example, is a short example about what? Footing design. So you know Q-save and this type of question. What is the failure mechanism for gravity retaining wall? This is also one important question. You can find it in week, I think week 6. Not week 6, week 7. So
Sorry, I skipped that one.
which one?
41? Sorry, I was writing down notes. What was the second question asking?
Yeah. No, I will just. This is the answer of the question. For the retaining wall, what is the failure mechanisms for retaining wall? So this is 3. So in week 7 or lecture, which lecture is this? Week 9, lecture 8. Week 9, sorry, lecture 7. So week 9, lecture 7, this is the failure mechanism for retaining wall. So how many failure mechanisms? 3. But you need to draw a sketch, for example. Okay? Not just mention 1, 2, 3. So we have sliding, overturning, and bearing. Okay?
What's that? What's the bearing?
Bearing means the soil is not strong enough to carry it, so it will, settle. Okay?
Three mechanisms.
Yep.
What was the second question?
Second question, rectangular footing dimension. So if you have a column load, what is the bearing pressure? So what is the bearing pressure? The bearing pressure, or Q, equal to what? The load divided by the footing area. If the soil ultimate bearing capacity is 450 kPa, what is the factor of safety? Yep.
It's like what we did in the assessment, isn't it?
Yep. Okay, so for example, this 125 divided by 2.5 times 2.5. So this gives us a value of 200 kBA. So Q equal to 200 kBA. So a factor of safety will be QU divided by Q, which is 450 divided by 200. So how much is this one? 2.25. Okay.
What about the calculated questions? What are they gonna do?
Yeah, for the calculations, this one also, do you know this one? Tau? Tau, this one also a simple one. Tau equal to what? Don't know? The shear stress. What is the shear strength of the soil with cohesion of C and friction angle of phi under effective stress of 166? So where is this one? This one also in week. I just try to link it with the week so that you can refer back to it. To remember. We already have solved this one in the week 12 as well. So this is the formula. We have solved this one in week 12 lecture. So tau equal to C plus sigma tan phi. So tau equal to C plus sigma tan phi. So it is a straightforward one. This question just to give you marks. So sigma 166, phi 30.2, C 8, so you can get tau. Okay, so the question will be, for example, slope stability 1, either method 1 or 2. Do you know method 1 or 2? The two charts I mentioned in the first part of this lecture. So method 1 is chart Howick and Bray. Method 2 is Stewart chart. Okay, one of them, not both. So the second one also about pavement. So the pavement also has two parts. One of the design ESA, the tracks and so on. One of the basement base and sub base thicknesses. Okay. So these are the type of problems we can have.
Any other calculation ones?
Now this is the main one. So because we have already here the bearing. So the calculation in this course, the bearing, the footing design, and the slope stability design, and the pavement design.
So in the exam, that's the only two we're gonna get.
Yeah, and also can get this part.
That is more,
Because it's
short
simple,
question.
yeah, short question or small question. So
So either slope stability method 1 or 2, and then the second one will just be the
yeah, the change of the type of track, whatever the type of track else,
nothing
and
else.
nothing else.
Beautiful.
Okay,
Well, that makes me less stressed.
good
That
now.
makes me feel less stressed, because I don't.
Less stress or more stress?
No, less stressed, because at least now you know what's gonna be in the exam and what's gonna be cut down.
Yeah, that's good. Okay, I will end the session now. Thank you, guys.